Okay, before we get into any of the real news, I need you to react to this because I read it twice to make sure I wasn't hallucinating. Researchers in Sweden made a 3D printing material out of baker's yeast, like bread yeast.
Bread yeast, as in the thing that makes a loaf rise.
That's the one. This was a 3D natives piece, Chalmers University. They mixed the yeast with wood cellulose, seaweed alginate, a little vegetable glycerol, and water, and you get a biodegradable construction material, building material, out of basically a pantry.
I love that the ingredient list reads like a sourdough recipe with one weird addition, and the pitch is it replaces plastic in building applications, which, sure, on a bench. The word eco-friendly is doing a lot of lifting before anyone's run a life cycle analysis. But honestly, as a let's see what sticks research project, it's delightful.
It's the good kind of weird. Nobody's claiming you're printing a skyscraper out of brioche tomorrow, which, funnily enough, is a nice contrast to one of the stories we're getting to later, but I'll let that sit. So here's the week, if I had to put a point on it. This was the week big, serious money stopped treating additive like a prototyping toy and started treating it like infrastructure. TDK, the giant Japanese electronics company, is spending up to $400 million on a metal printing startup. The Air Force is bolting printed parts onto its entire C-17 fleet. And then, because the universe demands balance, somebody launched a concrete printer that bolts onto a crane and promises to build 100-meter towers.
3 guesses which of those I'm most curious about, and the first 2 don't count.
The crane?
The crane. We'll save it. The one I actually want to dig into is TDK, because that's the deal that should make people sit up. It's not hype, it's a checkbook. When a company that big buys a printing process you've probably never heard of, that tells you more about where this industry is going than any press release ever will.
And then we've got a new large format SLS from Formlabs, a high temperature aluminum out of Oak Ridge, the Air Force microvanes, a skunkworks drone, and, quietly, somebody's trying to revive Thingiverse again. Let's start with the $400 million. So TDK is acquiring a San Diego company called Fabric 8 Labs for up to $400 million. This was all over the trades this week. TCT, voxel matters, 3D print all had it. And the technology is the part I keep coming back to because it's not laser melting metal. It's something called ECAM. Jordan, this is your wheelhouse. What is it actually doing?
Okay, so quick version for anyone who hasn't gone down this particular rabbit hole. The metal printing most people picture is powder bed fusion. You spread a layer of metal powder, blast it with a laser, melt it, repeat, lots of heat, lots of energy, lots of stress in the part. ECAM stands for electrochemical additive manufacturing, and it's a completely different animal. It's basically electroplating, but with control. You're depositing metal out of a solution, atom by atom, at room temperature.
Room temperature, so no melting at all.
None. And that matters more than it sounds. When you melt and re-solidify metal, you get residual stress, you get grain structure problems, you get warping. If you can grow the part electrochemically instead, you sidestep a whole category of headaches. And critically, you can make really fine, really pure copper structures, which is the part that explains why TDK wanted it.
Right, because this is being framed as an AI infrastructure play, which I'll admit took me a second. What does a metal printer have to do with AI?
Heat. AI data centers run these chips that throw off absurd amounts of heat, and the bottleneck on building more of them is cooling. High purity copper is the gold standard for thermal management. It pulls heat away beautifully. And if ECAM can print intricate copper cooling structures that you couldn't machine conventionally, then suddenly you've got a manufacturing process aimed straight at the hottest market on the planet, literally and financially.
Okay, so that's the why should I care for me. It's not cool new printer. It's a giant just bet that this is how you cool the AI boom. That reframes it completely.
And it puts it in scale. $400 million, for context, Desktop Metal paid around $575 for X1, and that was a landmark deal. Stratasys Origin was $100. So this is genuinely one of the biggest additive acquisitions in years. That's not a tuck-in. That's a strategic commitment.
I do want to flag one thing. Every write-up calls ECAM production ready. Is that an established fact, or is that TDK's implied bet?
That's the bet, and I'm glad you caught it. None of the sources cite independent production volumes or customer case studies. So When you read production ready, the honest translation is a very sophisticated buyer did its due diligence and concluded it's close enough to write a 9-figure check. That's a strong signal. TDK doesn't fling money around, but it's their assessment, not a benchmark anyone published.
Which is a fair distinction, but I don't want to overweight it either. The check is the validation. A company like that doesn't acquire a process and then discover it doesn't work.
No, exactly. And here's the part I find genuinely encouraging. For years, the metal additive manufacturing story was someday this will matter for production. This is a someday arrive story. A non-additive electronics giant looked at a printing process and saw it as core to their roadmap, not a side experiment. That's the maturation we keep talking about happening in real money.
And it folds Fabric Ada Labs into TDK's global manufacturing network, which is the thing a startup almost never gets. Instant scale, instant supply chain. That's the bit that makes me think this actually ships product, rather than dying in a lab.
That's the strongest argument for it being real. A clever process in a startup is a science project. A clever process inside a company that already makes billions of electronic components is a product line. The technology was always interesting. The acquisition is what could make it matter.
Speaking of stuff getting more accessible, Formlabs launched the Fuse X01 this week. Large format ESLS starts at $84,999. This was on 3D Printing Industry, TCT Fabaloo. And the headline number is that it's roughly half the cost of comparable industrial systems.
Quick translation, SLS is selective laser sintering. You've got a bed of nylon powder, a laser fuses it layer by layer, and the unfused powder around your part acts as its own support. No support structures to snap off. It's fantastic for functional plastic parts. An industrial SSLS has historically started at 150, 200K and up, so 85 is genuinely aggressive.
They're also claiming 3x throughput and saying it's already running at Tesla's Gigafactory.
And this is where I put my hand up, 3x compared to what their own baseline is the Fuse 1, which is a compact benchtop machine. So 3x faster than a small benchtop unit is not the same as 3x faster than an EEOS production system. It's Formlabs' own number, no independent test methodology, no stated conditions. It might be great, but 3 times is a comparison floating in space until they tell you what the baseline is.
And the half the cost thing, that's machine price, right? Not total cost of ownership.
Right, and that's the one that bites people. With SLS, your real cost is powder, post-processing, the powder handling setup, the service contract. The sticker is half. Is the running cost half? Nobody said. I've watched plenty of teams buy a cheap industrial machine and then discover the consumables budget is where the money actually lives. So promising machine, real price drop. Just don't let the marketing math do your purchasing decision for you.
The Tesla mention is also single source via Formlabs. No scale, no detail on what they're printing.
It's a logo on a slide until we know more. Used at the Gigafactory could mean a production cell, or it could mean one machine in a corner printing jigs. Both are fine. But they're very different stories.
Let's do the one that actually made me go, ooh, us. Oak Ridge developed a printable aluminum alloy called Dualumin 3D that holds its strength at 400 degrees C. That was on 3D Printing Industry. 400 degrees is wild for aluminum, isn't it?
It really is. Most aluminum alloys start losing the plot above 200, 250 C. They go soft. So the whole reason aluminum gets ruled out of hot applications, engine internals, certain aerospace parts, is exactly this. If you've got an aluminum that stays strong at 400, you've just handed engineers a lightweight option in places they could only use steel or titanium before.
They took it from concept to full-scale automotive piston prototypes in under 3 years, which for a national lab feels fast.
It is fast, and OR&L is about as credible a source as exists. The thing I want before I get too excited, the article gives the claim but not the numbers. Retain strength how? 50% of room temperature strength, 80%. For how long under load? Because 400C sustained for a part that's load-bearing is a very different ask than a quick thermal spike. The mechanism matters, and it's not spelled out.
So filed under genuinely exciting, still research stage.
Exactly that. Lab success to a qualified, costed production powder is a long road. I've watched alloys that looked incredible in a paper take a decade to show up in anyone's machine. But this is the good kind of news. Real lab, real prototype, clear use case. I just hold the champagne until the data sheet lands.
One more quick one, more of a market note. Chinese state media reported China exported 2.46 million consumer 3D printers in just the first 4 months of 2026. That was on 3D Print's Asia Watch column.
2.46 million in 4 months. If that's accurate, it's a staggering number. That's the bamboo and creality and any cubic effect at full tilt. I just gently note the source is Chinese state media. No independent customs corroboration. The figure's oddly specific, which lends it some credibility, but the provenance is worth keeping in the back of your mind. Directionally, though, nobody doubts China owns desktop hardware right now. All right, my corner of the show, 2 aerospace stories this week, and they're a great pairing because one is what mature additive looks like, and the other is what early additive looks like dressed up as mature. Start with the Air Force. This one's the real deal. They announced they're equipping all 222 C-17 transport aircraft with 3D printed microvanes within the next year. Voxel Matters had it.
Microvanes? These are little aerodynamic fins?
Small aerodynamic devices, yeah. You bolt them on near the rear of the aircraft and they smooth out the airflow, reduce drag, and you save fuel. The aerodynamics isn't new, that's established. What's new is the manufacturing approach. Instead of tooling up a traditional production line for a part you're putting on a few hundred planes, you print them. No retooling, no minimum order quantity headaches.
And 222 aircraft? That's a lot of confidence in printed parts on something that flies.
It is, and that's why I like it. This is fleet-wide deployment on an operational military aircraft. That's not, we printed a demo part once. Now, fair caveat, these are small, non-structural add-ons. If a microvane fails, it's not the same as a turbine blade, letting go. So it's a smart entry point. Low risk, real benefit, exactly where you'd want additive to prove itself on a fleet.
The 1-year timeline? Believable?
It's their stated timeline and it's aggressive, but because the part is small and simple, it's actually plausible. The thing nobody's independently confirmed is whether they've got the print capacity to do 222 aircrafts worth in 12 months. That's a production throughput question, not a can we print it question. I bet they hit it, but I'd want to see the line.
Now the second one, Lockheed, Skunk Works, and Divergent built a drone.
Right. Skunk Works partnered with Divergent Technologies and produced a 9-foot wingspan unmanned aircraft concept to first article in under 12 months. Also, Voxel Matters, and the headline reads like a triumph, and it might be one, but I want to be careful about what first article means because it's doing a lot of work in that sentence. Where
Translate first article for me.
First article is the first physical unit you build off your design. 1, it is not a flight qualified, certified, production ready aircraft. So concept to first article in under a year could mean they designed and fabricated one airframe in 12 months, genuinely fast. Or it could be folding in requirements, design reviews, and testing. The scope is unclear, and that gap is the difference between impressive prototype and we can manufacture these.
And Divergent. Their whole thing is automotive structures, right? The car chassis stuff.
That's their proven domain. Their DAPS platform makes lightweight vehicle structures. Applying it to aerospace is interesting, but it's a different beast. Different loads, different certification, different materials. So the real question I'd ask isn't, did they build a drone fast? Clearly, yes. It's what had to be adapted and how far is this from something you could field at scale. Building one is a demo. Building 100 that fly missions is manufacturing. Don't confuse the two.
There's a nice thread between these and the qualification story too, isn't there?
There is. That's the third one. America Makes and NCDMM awarded $2 million to a project led by Dendrite to build an AI-based framework for material qualification in laser powder bed fusion. 3D printing industry and TCT both covered it. And this is the unglamorous problem underneath every story today.
Qualification being proving the material does what you say consistently enough to certify it?
Exactly. In aerospace, medical, defense, you can't just print a part and bolt it on. You have to prove the material's properties are reliable batch after batch, machine after machine. That qualification process is slow and brutally expensive, and it's the single biggest thing holding additive back in regulated industries. So the idea of using AII to identify and quantify the risk faster, that's aimed at the real bottleneck. It's just early. 2 million projects starting, no results. It's the right target, but it's a hypothesis with funding, not an answer.
Let's come down to earth and talk hobby stuff, because there's a fun one. Prusa released ColorMix shading, and we actually flagged ColorMix as an open source tool last week. This is the shading utility. It applies lighting-based color effects to your prints, simulating how light plays across colored surfaces. Fabloo had it.
So it's a creative tool for multi-material prints, not a performance claim, just here's a way to make your colored prints look richer, which for once I have nothing skeptical to say about. It does a thing. The thing is aesthetic. You'll either like it or you won't.
This is squarely my wheelhouse, because I print a lot of Warhammer terrain, and the difference between a flat multicolor print and one where the light reads like there's actual depth. That's everything for tabletop stuff. If this gives me shading without me having to dry brush every crevice by hand, I'm extremely here for it.
See, that's the use case that makes it click for me. On a functional bracket, who cares? On a model you're displaying, baked-in shading that saves you an hours of paint is a genuine win. Reflects a maturing multicolor ecosystem. The hardware caught up, now the software is getting playful.
The other maker story, somebody's trying to revive Thingiverse again. My Mini Factory, who took over managing it, outlined a strategy with a roadmap of new features. Also, Fabloo.
Oh, Thingiverse, the phoenix that keeps almost rising. How many revival attempts is this now? It's the platform that everyone learned to print from, and then everyone slowly drifted away from because it got neglected under previous ownership.
It's still the front door for newcomers, though. That's the thing. When someone gets their first printer and Google's free 3D models, Thingiverse is still where a ton of them land. So a real revival would actually matter for the people just starting out.
It would, if it happens, and that's my whole reaction. It's a roadmap, no specific features detailed yet, and the genre of we're going to fix Thingiverse has a rough track record. So, the honest question is just what's actually different this time with My Mini Factory steering? I want it to work. I've been burned by enough coming soon to wait for it's here.
Okay, the crane. You've been waiting all episode. Take it away.
I have. So, an Australian company, Lutin 3D, launched the Ascend A27, which they're calling the world's first tower crane-mounted concrete 3D printer, capable of building structures up to 100 meters tall. 3D printing industry covered it. And I want to be fair. The core idea is legitimately interesting. Most concrete printing is gantry-based. A big frame the print head rides along, which caps how tall you can go. Mounting on a crane to go vertical is a real conceptual swing.
I hear the but loading up.
2 of them. First, world's first. That's a claim with zero evidence behind it in the source. And world's first claims almost always survive only because of how narrowly you define the category. Other non-gantry construction printing has been demonstrated. Second, and bigger, capable of 100 meters is a claimed capability, not a demonstrated one. There's no completed 100-meter structure. There's no completed structure at any height cited.
So has it actually printed anything?
That is exactly the question, and the source doesn't answer it. And here's why it matters. A crane sways. It deflects in wind. At 100 meters up, you've got wind loads. You've got vibration. You've got the problem of pumping concrete that high and getting it to cure properly before the next layer. Gantry systems are rigid precisely to avoid this. Crane mounting trades your rigidity away for height, and none of those engineering problems are addressed in the announcement. That's not a footnote. That's the entire hard part of the idea.
Let me push back a little, because I don't want to be the guy who dunks on every ambitious idea. Somebody has to try the wild version, right? The yeast people in the cold open get a smile, but a crane printer gets the hammer?
That's a fair shot, and here's my distinction. The yeast researchers said, we made a material, here's the composition, it's early. That's honest research. Lutin said, world's first 100 meters, here's pricing, with a product name and no demonstrated build. That's a press release wearing a spec sheet. I'm not dunking on the ambition. I'm dunking on the gap between the claim and the evidence.
Yeah, okay, that lands. When you frame it as show me anything you've actually built, the silence is the answer.
And look, if they print a real building, even a 30-meter one, I will happily come back and eat my words on air. The concept deserves to be tried, but until there's a structure standing, this is a concept with a marketing budget, and we should call it that.
Funny how that rhymes with the other hype-flavored one this week, Mastrex and their EMX 300, which we actually talked about back in episode 1.
Same playbook, smaller. They're calling the EMX 300 the industry's most affordable LPBF metal printer at $185K. And like we said last time, most affordable compared to what Exact Metal and One Click Metal have systems right in that range with actual track records. Most affordable from an unknown vendor with no published specs and no customer references is a superlative looking for a market. And remember, with LPBF, the machine is half the cost. Powder handling, inert gas, safety, service can double it. A cheap sticker on a bare machine isn't a bargain. Show me the build volume and the turnkey number.
All right, one thing to try this week, and this one's easy and actually fun, straight off the Prusa News. If you've got a multi-material setup, go grab color mix shading and run it on something you'd normally just print flat. A bust, a piece of terrain, anything with surface detail.
And my one tip, start with a model that already has good geometry to catch the light, deep recesses, raised detail. The shading effect leans on the surface having somewhere for the light to fall, so a smooth, featureless print won't show you much. Pick something sculptural and you'll actually see what it does.
Perfect. Report back. I'll be doing it to an entire table's worth of ruins, so that's the week. A giant betting $400 million on metal, an air fleet going additive, and a crane that's making promises. Go print something, and we'll talk next week.